researched the movement of air in the upper parts of the atmosphere, above what we would typically call the weather. Atmospheric waves transfer momentum from the lower parts of the atmosphere into other parts of the atmosphere, and when they do that, they force large-scale circulations that can change the nature of the atmosphere. These waves are made by airflow over mountains and landscape features, but they're also made by the air movements associated with cold fronts and changes in the jet stream. So the waves can be measured by making measurements of the wind using atmospheric balloons, but also using atmospheric radars. We operate 3 atmospheric radars at Davis Station. The 3 atmospheric radars look at different parts of the atmosphere. So one mostly looks at where we would call the weather, so the troposphere and the lower stratosphere. It measures the wind speed in that part of the atmosphere every few minutes. Another one looks quite high up in the atmosphere, between about 70 and 100 kilometres, in an area called the mesosphere and lower thermosphere. Once again, it does it every few minutes. And then finally, we have one that detects meteors as they come into the atmosphere, and the trail of the meteor gets blown along by the wind, and we're able to measure the wind speed by gathering a whole stack of those detections of meteors. Interestingly, that last radar can also be used to study the meteors themselves. A lot of the data taken is fed to the Bureau of Meteorology for them to use in their weather forecasting. The other radars are used by my colleagues all around the world for studying wave and other activity on a global scale around the Earth.